Hey, good day, guys. Thursday here. I was gonna say morning or afternoon, but I have two different classes. So one's in the morning, afternoon, so I can't really say one or the other right now. But hey, heads up. Thursday. Oh, no, heads up. Sorry, excuse me. Today's Thursday, the 20th of March, February 2020. So a lot of 20s there. 20. If you look over the sideboard here, SWBA. Remember, our students will be able to, and it's dividing monomials today. We're dividing monomials in section 6.2. Now, last time we went over these three different rules that we had. We had these three different rules for exponents. Talking about rules of multiplication. Now we're talking about rules of division, kind of the other side of the coin there. Okay. So we're going to start here with dividing monomials. Now, if we have the same base a, once again we're starting with the same base. Remember that the base is whatever is being raised to the power. So we have the same base a here. So we have a to the mth and then over a to the nth there. A to the mth over a to the nth there. What we're going to do is we're going to take that same base a and raise to the m minus nth power, the top power minus the bottom power. Let's look at some exploration of this, just like we did last time. So if we have a to the 6th over a to the 2nd, the top would be 6 a's multiplied together, a times a times a times a times a times a. The bottom would be a times a, two of them. Now, a little aside real quick, let's step back a moment here. Don't have to write this part down. But if we step back for a moment here and we recall that, hey, if I have 6 divided by 2, 6 over 2 in a fraction. Well, 6, that's the same thing as 3 times 2, isn't it? So 6 is the same thing as 3 times 2. Now I can take this 2 and this 2, and since these are multiplying together on the top, 3 and the 2, I can divide those 2's out and say, hey, 2 divided by 2, those both become 1. 3 times 1 ends up being just 3. Ends up just being 3 over 1 or just 3. And we know 6 over 2 is just 3. Now we commonly end up just kind of going about and say, oh, well 6 over 2, 2 goes onto both, we get 3. Same idea, same premise here. Okay? Well, we're able to go through these and say, hey, an A on the top and the bottom. Those both can divide out and become 1. Same thing here. But now we run out on the bottom, so we can't keep going. We can't keep crossing out the top because we don't have enough on the bottom to also keep crossing out, aka dividing out. So now we have 1, 2, 3, 4. 4 a's, so a to the 4th, times 1, which is just a to the 4th. On the bottom, you just have 1 times 1, which is 1. So you just have a to the 4th, my pen's being weird there, a to the 4th over 1. Let me kind of try and see if I can fix my pen there for a moment. Oh, that didn't erase what I wanted, but that's okay. So you end up having a to the 4th over 1, which is just a to the 4th. I guess I had that there a couple times. So really just didn't need that. There we go. That's better. So a to the 4th is our answer. Now how we get there, once again, from the start to the beginning, if we follow this expiration, a to the nth over a to the nth, a to the 6th over a to the 2nd. We took a to the m minus nth. A to the 6 minus 2. What's 6 minus 2? 4. The same base, dividing the monomials, we can just subtract the exponents. Now, when I look at this, I see this being a great parallel to what we had with multiplication. I see this as being a great parallel to what we had with multiplication. Whereas with multiplication, if they had the same base, we added them. Well, what's the opposite of multiplication? It's division. So we're going to do the opposite of adding, like we did for multiplication. So we're going to subtract. So when dividing powers with the same base, subtract the exponents. Now during this video, guys, you guys might need to pause and go back. I'm not going to go through this at our normal class pace because I don't have students ask me questions right now. So I want you guys to pause this as you need and go back as you need to think through, oh, do I just need to do that one more time? Okay, those kind of thoughts. Or if you guys want to pause before I do an example and see if you guys can try the example yourself and then go and then click the video again and see if you get it right or compare it to what I did, that'd be a great idea. I really encourage that. Because once again, I'm going to go a little faster than I would normally because you guys have the option of just pausing and rewinding here, okay? So number 1, s to the 3rd over s to the 2nd. Same base, s and s. So we can say, okay, well, s to the 3 minus 2. What is 3 minus 2? It's just 1, so s to the 1st, okay? And now in the future, I won't even be writing this step here, the s to the 3 minus 2. I'm just going to jump straight to the s, okay? Because we know what 3 minus 2 is, and it's 1. I don't have to write that 1. We look at example 2 here, x to the 5th, y to the 3rd of z over x squared y. Well, we see on the top and the bottom we have the same base x raised to the exponent of 5 and exponent of 2. Well, 5 minus 2, that's 3, so x to the 3rd. Y to the 3rd over y. Well, this y is secretly being raised to the first power, same base of y. 3 minus 1 is 2, y squared. Z, I see it up here. I don't see anything to subtract with down there, so it just hangs out. It's still just z. So we have x to the 3rd, y squared, z. Maybe I'll try making this a little bit bolder, just a tiny bit. Oh, that's too much. Let's go back here. There we go. That might just be just right. We'll see. Be kind of like Goldilocks, just right. Don't worry, I'm still making lame jokes even on the video. Last one here, b to the 14th over b to the 4th, same base. 14 minus 4 is 10. B to the 10th is our answer. Going on to rule number 5 here. Rule number 5, we're going to do a power of a quotient. In earlier, rule number 2, we had power of a product. Now we have power of a quotient. A quotient is a division product, it's a fraction. So if we have a over b all being raised to the power of m, we have a quotient being raised to a power. Then what we're going to do is very similarly to how we distributed the exponent to the exponents, multiply the exponents to the exponents in the parentheses. We're going to do the same thing, and now we do it to the top and to the bottom here. So let's look at this expression. We're going to have a over b all being squared. A over b all being squared. So that's a division problem, a divided by b, because fractions are division problems. And whenever anything's squared, it just means there's 2 of them multiplying together. So in this case, there's 2 of everything in this parentheses. So it's a over b times a over b. Now for multiplication, we learned that, hey, we multiply straight across. A times a is a squared. B times b is b squared. A squared over b squared is what we get. And if we were to have jumped there from early on, how we would have gotten there was saying, okay, take this 2, multiply times 1 that the a is being raised to. Take this 2, multiply times the 1 that the b is being raised to. Bada bing, bada boom. You have a squared over b squared. So, to find the power of a quotient, you find the power of the numerator, which if we remember that is the top of the fraction, and the power of the denominator. The power of the denominator, which is the bottom of a fraction. Numerator is the top, denominator is the bottom, right? So let's practice by simplifying these expressions. Once again, if you guys need to hit pause or rewind, feel free to now, okay? 2x to the 4th over 4, all being raised to the power of 3. So what we would do is we take this power of 3 and we distribute to everything in the top and everything in the bottom. When I say everything, we mean every power. So we don't take it times the 2, we take it times the 1 that the 2 is being raised to and get 2 to the 3rd. Don't take times the x, we take times the 4 that the x is being raised to, x to the 12th. On the bottom, we'll take times the 4, we take times the 1 the 4 is being raised to, 4 to the 3rd. Now from there, we can keep going, because 2 to the 3rd is 2 times 2 times 2, aka 8. And that's still x to the 12th. On the bottom, 4 times 4 times 4, 4 cubed. 4 times 4 is 16. 16 times 4 is 64. And then we look at that and say, oh wait, we can simplify that more. What goes into both 8 and 64? If you said 8, you're right. 8 goes into itself once, so it's just 1 times x to the 12th, aka x to the 12th. We don't need to write 1 times anything. It goes into 64 8 times. So we get x to the 12th over 8. Now, what if I told you that there's a way we can go through this with getting smaller numbers, but we get the same answer? I like that idea. So let's say we restart the problem here. Can I do anything inside this parenthesis? I think the answer is yes. What I can do is I can simplify this 2 and this 4. What goes into both numbers? It's 2. It goes into 2 once, it goes into 4 twice. So now we have x to the 4th over 2, all being raised to the power of 3. Now, when I take this 3 and distribute it into the other exponents, 3 times 4 is still x to the 12th. That didn't change. 3 times this power of 1, the 2 is being raised to, is 2 to the 3rd. So all of a sudden we have x to the 12th over 2 to the 3rd. Now we already covered earlier that 2 to the 3rd is 8. So we end up with x to the 12th over 8. X to the 12th over 8 there. That's our answer, which is the same answer we got up here in the light blue, the other way. In this way, we got way smaller numbers. The biggest number we had to deal with was 2 cubed. Earlier we had to deal with 4 cubed, which got up to 64. This can really help us later on. Let's take a look at number 2 here. 5x to the 5th y all over 6, which is all being raised to the second power. Nothing we can simplify here inside the parentheses this time, unfortunately, but we can distribute this 2 to the exponents. So 5 becomes 5 squared, x becomes x to the 10th, remember we're multiplying, and y becomes y squared. 6 becomes 6 squared, because it was 6 to the 1st. Go through this and say, hey, wait, before we're done, I bet I can do something with these exponents. 5 squared is 5 times 5, aka 25. 25! Woo! Gotta love it. X to the 10th, y squared. All over 6 squared, which is 36. Can't simplify that anymore. We're done. By the way, quick pun alert, okay? Quick pun alert, I do these even on the video, don't you worry. Why did 4 not ask out 5? Why didn't 4 ask out 5? Because 4 was 2 squared. He was 2 squared. That's funny. Okay? If you're not laughing right now, you should reevaluate your sense of comedy. Okay? Rule number 6, 0 exponents. We're saying anything raised to the power of 0 is going to be 1. How can that be? What's that mean? Let's look at this exploration. Let's say we have a to the 5th over a to the 5th. We do the same thing we've been doing. A to the 5th is a times a times a times a times a. 5 of them on multiply on the top. Bottom's going to be the same thing. Now, if we remember from earlier, we can just simplify those out. So we have, for every time we have an a on the top and a bottom, and they're multiplying, bada bing, bada boom, those both divide to 1. A divided by a is 1. A divided by a is 1. So on and so forth. And we can just keep going until we run out on the top or the bottom, or in this case, we ran out on both. On the top, 1 times 1 times 1 times 1 is 1. On the bottom, same thing. So we end up just getting 1. Mr. Kossel, I thought we were talking about exponents of 0. I don't see an exponent of 0. I saw 5s, and I see the number 1 at the end. Where is the exponent of 0? Excellent math question. This is why I love you guys. A to the 5th over a to the 5th. Well, we just learned 2 rules ago, rule number 4, that when you divide monomials with the same base, like we have here, we can subtract the exponents. What's 5 minus 5? 0. So that's a to the 0, which is the same thing as 1. So that's how we get that. We're saying anything raised to the power of 0 ends up just being 1, and this is why. And it doesn't matter what number you use, it doesn't matter what variable you have, it doesn't matter how much you have there. If it's raised to the power of 0, it's automatically 1. So any number raised to the power of 0 is 1. Let me just go to some length of showing that. 5 to the power of 0, that's 1. Negative 22 to the power of 0, that's 1. 4ab squared d all over 5, all being raised to the power of 0, 1. I don't care what there is being raised to the power of 0, it's 1 no matter what. Then on to rule number 7, negative exponents. Negative exponents here. Okay? Common misconception is that a negative exponent makes the number negative. Not true. A negative exponent reciprocates it. Reciprocal, aka refliprocal as we often know it, ends up just moving it from the top to the bottom or the bottom to the top of a fraction. A to the negative nth is secretly over 1. So what you do is you flip it, you put it on the bottom, and you make it positive. It's still the same a to the nth. It didn't become a to the p, didn't become a to the q, didn't become b to the n, and it stayed a to the n. It just changed from a negative exponent to a positive exponent. Let's look at some exploration again. A squared over a to the 5th. Well, we know a squared over a to the 5th is going to be a times a on the top, 2 of them. On the bottom, we have 5 of those a's being multiplied together here. Now, once again, we can go through and simplify it the same way we've been doing this. So I can take a times a divided by a is 1, excuse me, I said times. A divided by a is 1. Now, I ran out on the top, so I can't keep going. 1 times 1 is 1. On the bottom, though, I still have a times a times a, 3 of them. So that's a to the 3rd. So this is 1 over a to the 3rd. Once again, you might be asking, Mr. Kossel, what happened to the negative exponents? You said negative exponents. Well, same thing as last time, guys. If we take this a squared over a to the 5th, and we subtract these exponents because we're dividing the same base, 2 minus 5, that's negative 3, a to the negative third, which is the same thing as 1 over a to the third. Once again, it didn't change the exponent, it just changed whether it's negative or positive. And we'll see here what this means in a moment on example 2 on the next page. But we're saying that a to the negative nth is the reciprocal of a to the n, and it works the other way too. The reciprocal of a to the negative nth is a to the n. They're reciprocals of each other. And we'll see what that means in a moment here. So let's go and flip this page. Let's start with example 1 here. And we are asked to simplify each expression. That's what it says in our instructions here. And what it means to simplify is that there is no more math you can do. We have positive exponents. We can't divide any more things. We can't simplify anything more things. We can't multiply anything more things together. We can't add any more things together. It's all taken care of. Well, number 1, we have a negative exponent. We don't want them to be negative. So what we have to do is we say this is over 1. So to make it positive, we're going to make it 1 over x to the 5th. It's still the same x to the 5th though. Here's the way I like to remember this, guys, is that sometimes, as a teenager, I was there, you get annoyed with your parents. It happens. They get annoyed with you too, spoiler alert. Okay, sometimes they get annoyed with you too. Okay? But sometimes you get annoyed with your parents. So let's say, right now, you're like x to the negative 5th. You're upstairs with your parents. You're upstairs on the top of the fraction bar here, the numerator, you're upstairs, and you're home with your parents. And you're getting a little annoyed with them. They're making you negative right now. So what do? You give yourself some space, you go downstairs. And what happens when you go downstairs, you give yourself some space? You're positive now. Now you're still the same person. It's not like all of a sudden you change from x, and all of a sudden you're an A. No, you're still an X. Okay? You're still the same person. You're still a sophomore. Okay? You're still a boy or a girl. Okay? You still go to Plattsmouth High School. None of those things changed. It's just where you're at changed. And because of that, you're more positive. So it's still x to the 5th. Now, number 2, the opposite is true. Let's just say we're downstairs with your parents. Maybe you're downstairs with your parents in your house, and they're making you negative downstairs. What can you do, guys? Go upstairs. A to the 2nd over 1, which we don't even need that over 1, so just a to the 2nd. Once again, you're still the same person. Instead of just being downstairs and negative, you're upstairs and you're positive now. So when you're negative, you just want to go to the other place. You want to go either upstairs or downstairs, wherever you're not. And you'll become positive, but you're still the same person. And number 3 here, 4, a squared being raised to the 0, b to the 3rd. Well, inside this parenthesis, we can't do anything. So we still have to follow our PEMDAs, our order of operations. Please excuse my dear Aunt Sally. Okay? Parentheses coming first. Nothing can be done inside this parenthesis. Exponents. We can't do anything with this exponent 2, but we can do something with this exponent of 0. Multiply it times the power of 2. 2 times 0 is 0. 4 times a to the power of 0, b to the 3rd. Now what did we cover? Was anything to the power of 0? 1. 4 times 1 times b to the 3rd, aka 4b to the 3rd, which is our answer. Now commonly, guys, what I'll end up doing here is I'll just say, okay, this is being raised to the power of 0. I'll just go ahead and consider that 1. I'll skip this step here, okay, and I'll just jump straight to that. Okay? And sometimes I'll even skip this step here to say, well, I know if it's multiplied by 1, I don't even have to write it. Okay? On number 4 here, we got some stuff going on. We got some multiplication on the top, multiplication on the bottom, got some division going on with that fraction mark. Very first thing I want to take care of, though, is this negative exponent. I don't want that. So what I got to do, I got to send it upstairs. The A does not get sent upstairs. The 24, haha, does not get sent upstairs, and the C does not get sent upstairs. The only thing that gets sent upstairs is the B, because the B is the only thing with a negative exponent. The 24, haha, A, and the C all have positive exponents. So if I rewrite this here, I'm going to rewrite negative 8, A to the 5th, B to the 4th, C to the 3rd, and now this B to the negative 2nd goes upstairs, and it's B to the positive 2nd. It's supposed to be a 3 there on that C. All over 24, haha, a, b to the negative second is no longer down here, it's upstairs, c to the fifth. Now I want to go through and simplify more stuff. What goes into both negative 8 and 24? Because we can just divide this. Well, it's 8. 8 goes into itself one time. Do I have to write that? Nope. But it is negative. So a negative. On the bottom we have a 3. It goes into 24, haha, 3 times. Now we're going to practice the same division we did earlier. A to the fifth over a, same base, subtract the exponents. 5 minus 1 is 4. So it's negative a to the fourth. B to the fourth and b squared on the top. Same base, multiplying together. Add the exponents. 4 plus 2 is 6. So b to the sixth. Supposed to be a 6 there. C to the third over c to the fifth. Well, same base, dividing, subtract. 3 minus 5 is negative 2. So c to the negative second. Let me rewrite that. My pen went wonky. I don't like that. So it's c to the negative second. Now we don't want this negative exponent, so we have to send the c downstairs. Negative a to the fourth, b to the sixth, over 3c squared. Now we're done. We can't do anything more with a, b, c, is 3, and we have no negative exponents, which is good. Let's move on to number 5 here. 5x to the fourth, y squared, all to the power of 0. We can take this power of 0 and distribute it like we have been. 0 times 5 to the first is 5 to the power of 0. 0 times 4 is x to the power of 0. Y, or 2 times 0 is y to the power of 0. Wait, 5 to the power of 0, 1. X to the power of 0, 1. Y to the power of 0, 1. 1 times 1 times 1, 1. Did we have to even do that math? No! Okay? No, we didn't. Okay? The reason why we didn't have to do that math, guys, okay? The reason why we didn't have to do that math is because this is all being raised to the power of 0. We just said earlier, it's just 1. So you don't have to do that red math. You don't have to do this. Heck no, you're going to drop right to the orange. Number 6, 4p to the negative second, all being raised to the negative second. All over, 3p to the third, all being raised to the second. Now, before I move this p downstairs, I have to take care of this negative 2 outside of it first. I have to take care of that first before I can do that. So I'm going to distribute this negative 2 to the exponents inside. 4 is being currently raised to the first, so it becomes 4 to the negative second. P is being raised to the negative second. Negative 2 times negative 2 is positive 4. All over, I'm going to go ahead and distribute this exponent. It becomes 3 to the second, p to the sixth. Now I notice 4 to the negative second, I got to take care of that negative exponent. I'm going to send it downstairs. P to the fourth is still upstairs. 3 squared is still downstairs. We're going to put that 4 squared right there. And p to the sixth is downstairs. Now I can carry out and say, what is 3 squared and 4 squared? Well, p to the fourth over 9 times 16, p to the sixth. I got 9 because that's 3 squared. I got 16 because that's 14 squared. Well, now I can do 9 times 16 and get 144. And I can also do p to the fourth over p to the sixth, dividing, so we subtract the exponents. 4 minus 6 is negative 2, so it's p to the negative second. Now wait a second, do I want that negative exponent? Heck no, so I got to send that downstairs. Now if I send this downstairs and I have 144p squared on the bottom, I still have to have something on top, so what's left? A 1. Because there's secretly a 1 being multiplied with anything, so the 1's still left there. So we have 1 over 144p to the second. Let's go and take a look at number 7 here. 4p to the negative second, q squared, r to the negative third, all over. 2p to the negative first, q to the negative fourth, r to the negative first. Got a lot of stuff going on here. Got a lot of negative exponents. First steps first, let's figure out what's moving. Okay? Well, this p to the negative second is going to be moving. Q to the second will stay. R to the negative third is going to be moving. P to the negative first is going to move. Q to the negative fourth is going to move. R to the negative first is going to move. But this 2 is going to stay and this 4 is going to stay. Those constants out in front are staying. Now what we can do here is let's move things around. So we start with the 4 still, that's staying. This p is moving, so let's not write that yet. But this p to the first, that's moving upstairs. So p to the first, aka p. Q q to the second staying up here, and the other q is moving upstairs. So this becomes q to the fourth upstairs instead of q to the negative fourth downstairs. R to the negative third is moving downstairs, but r to the negative first is coming up, so it's r to the first. So on the bottom now, I still have this 2. The p to the negative first moved up, but this p to the negative second moved on down. P to the second. Q's all moved upstairs. R to the negative first moved upstairs, but r to the negative third moves down. Now from here, we look to simplify again like we were doing earlier. Like in the problem right above this, number 4. What goes into both 4 and 2? Well, 2. Goes into 4 twice, goes into 2 once. So we have 2 on the top. P over p squared, p divided by p squared, so we subtract the exponents because it's the same base. 1 minus 2, that's negative 1. Q squared times q to the fourth. When multiplying them, add the exponents, that's q to the 6th. R over r to the third, subtract the exponents, that's division of the same base. 1 minus 3 is negative 2, so r to the negative second. Let me fix that again. This thing is not liking me today, is it? R to the negative second. And we don't have anything on the bottom right now, but we don't want negative exponents. So 2 stays on the top, the p comes downstairs, and it's p to the first, q to the 6th stays upstairs, r to the second comes downstairs, become r squared. And that is our final answer. We can't do anything more to simplify there. Once again, this 2 did not go downstairs with the p, the 2 is raised to a positive 1, so that stays. Now guys, once again, if you guys struggled with this, if this was too fast of a pacing, what can we do? Well, we can go back and we can pause the video, rewind the video, rewatch the video, okay? Now, myself, Ms. McKinney, does have the worksheet, so please get those from her now, okay? And she also has the answer key in case you really need to ask her a question. So she can look and tell you if you guys got it wrong or right, okay? So let's use this time as work time. You guys can listen to music, but let's be wise with that, so don't let your phone be a distraction to you. If you're done, she knows, our sub knows, that you guys can be on your phone.